Hello, welcome to this video. This is 8-4. We're going to multiply and divide square root expressions. And the purpose of this video really is to brush up some old skills about working with radicals of numbers. And so what we're going to be doing is multiplying square roots as well as dividing them, and then really activating our knowledge of how we simplify a square root. Okay, so that's our learning target and our success criteria below. Just some prior knowledge questions really quickly. Go ahead and simplify this. And hopefully already you have recognized that square root of 36, say that's 6, square root of 4, that's 2, and thus this gives us 12. Not too bad, right? So there's a good warm-up. Something I also want to go ahead and activate for you in this lesson is the list of perfect squares. And some students struggle with these if they don't have them memorized off the bat, or they haven't committed them to memory. So right now, please make a note of these perfect squares in your notes. And here's a list of them, and I'll just go over them, right? The first one, 1 squared is 1, 2 squared is 2, 3 squared gives us 9, 4 squared, 5 squared, 6 squared, students are really strong here, 7 squared gives us 49, 8 squared, 64, 9 times 9, 81, 10 squared is 100, 11 squared is 121, and here's where some students start to fall off. 12 squared. I would argue those first 12 are super important, that you want to be able to recognize those. 13 squared is 169, and 14 squared gives us 196. I always remember these because 169, 3 times 3 gives you 9. And 3 plus 3 gives you 6, and then 196, the next one, is just the same last two digits, but flipped, right? And then 225 is 15 squared. Okay, so those are some perfect squares that you'll want to recognize and be able to utilize. Now, what is kind of, that idea that I can square a number, right? It's a number times itself. What about this idea of prime numbers? And a prime number is a number that can only be divided by itself and 1. So those are the only factors of these numbers, right? And really a fun fact here is 2 is the only even prime. You'll notice that the rest of these, are odd numbers. And that makes sense because it's a number that can only be divided by itself and 1. Well, the rest of the even numbers, right, are multiples of 2. So all those go out the window. So if we ever encounter these numbers today when we're looking at square roots, we can't simplify these. These are good, hey, you're done numbers. So let's cover some concepts, some properties of square roots. And this idea here, the square root of a times b, is really equal to, if I can break apart factors of my radicand. Again, this right here, make a note, this is called a radicand. That's the number underneath the square root. And that can be broken apart as the square root of a times the square root of b. And this obviously makes sense. Sometimes we forget multiplication gives us multiple forms. A times the square root of b can be written as a square root of b. Or you'll hear me say a root b. So here's our strategy today. We want to simplify square roots. The first thing to do is to rewrite the square root as a product of 2 square roots. So you want to rewrite the square root where the first square is the largest perfect square factor. So that's our strategy today. First, identify a factor that is a perfect square. Next, we'll simplify that square root, and then we'll write that simplified answer. Here's our first example. We're asked to simplify the expression, and we have the square root of 12. So I'm going to go ahead and rewrite this. This is the square root of 4 times the square root of 3. And again, I chose these numbers because 12 is 4 times 3, and 4 is the biggest perfect square inside of 12. That's a factor, right? I didn't choose 9 because I can't multiply anything times 9 to give us 12. All right, so there's your step 1. I identified a perfect square, and I rewrote this. And now I'm just going to simplify. The square root of 4 is 2, and the square root of 3 cannot be simplified. So I'm done. Square root of 12 is 2 root 3. Now this should seem familiar. You covered this in Math 2. Examples like this. So we're starting off hopefully with something that's familiar. Square root of 50. Anytime as I get multiples of like change, I get really excited because that means 25 is a factor here. So the square root of 50, that's 25 times the square root of 2, and the square root of 25 is 5. So square root of 50, that is 5 square root of 2. Okay, here's some practice problems. Please pause this video. Try these. This is your opportunity to get feedback, to shoot your shot, if you will, and see if you got it. Okay, so pause me. I'll go ahead and show you the answers here in a moment. Okay, hopefully you paused. Here is the solutions. The square root of 45, that is the square root of 9 times square root of 5. And the square root of 9 is 3. So plain and simple, this is 3 square root of 5. 28, this is the square root of 4 times the square root of 7, and square root of 4 is 2. So we have square root of 28 as 2 root 7. Okay, some more properties that we're going to cover now. Now we're going to go ahead and multiply some things together, and then go ahead and simplify if possible. But a property of square roots is that if I am multiplying 2 square roots together, I can combine them underneath a radicand. And I'll give you an example here. Square root of 2 times the square root of 3. Well, this is equal to the square root of 2 times 3 underneath this, which is 6. So the square root of 6. The second property is really, really important and really, really powerful. The square root of a value times the square root of that same value is just whatever that value is. The square roots cancel. And again, I'll use 6 here. So the square root of 6 times the square root of 6, that's just 6. The square roots cancel. And now you might be saying, okay, why is that? Well, a couple of ways I could write this. One, isn't using the property above, isn't this the square root of 36? And the square root of 36 is 6. But also, too, don't I have that times itself? Isn't that the square root of 6 squared? And so this power of 2 cancels with the radical, and we just get 6, okay? So we're going to utilize those properties. And then if possible, we will rewrite the square root as a product of 2 square roots, again, where we have the first square root is a perfect square, the largest perfect square in there. Simplify the square root if possible, and then we'll write our simplified answer. All right, let's check out these examples. Square root of 6 times the square root of 3. Okay, I can't simplify right away. I'm just going to multiply these. So 6 times 3, that's 18. Now 18, does that have a perfect square as a factor? It sure does. That would be square root of 9 times the square root of 2. And the square root of 9, we know, is 3. So this is 3 square root of 2, and there's our answer. Let's look at another example. Here I have 2 expressions that both have coefficients and they both have a square root. So what I'm going to do is I'm just going to go ahead and rewrite this. Don't you agree that multiplication is commutative? Commutative, meaning that A times B is the same thing as B times A. So all of these things are multiplying. 6 times square root of 7 times 5 times the square root of 2. So what I'm going to do is I'm just going to rewrite this. 6 times 5 times square root of 7 times the square root of 2. Okay, and if I put it like this, this won't freak you out. The above form will freak you out, but this form doesn't. 6 times 5, that's what? 30. Not bad at all. And then this form right here, square root of 7 times 2, that's, well, 7 times 2. That's 14. Now, can I simplify further? Well, the square root of 14 does not have a perfect square as a factor, right? 1 times 14, 2 times 7, that's about it. So we are done. Moral of the story here, if you're looking for a simplification, you can say multiply whole numbers with whole numbers. And radicals with radicals. Okay, last example here. We have 2 square root of 5 times the square root of 5. Okay, well, I only have one whole number, so I know I have a 2 out front. And then, hey, check this out. This is that case where I'm multiplying it times itself. So when you multiply something times itself, isn't that squared? Which is going to end up canceling those radicals, right? So this is 2 times 5. 2 times 5. Now, if you prefer it in a longer format, that's the quick way. This would be square root of 25, 2 square root of 25, which we know is just 5, right? So 2 times 5. I'll give you another look at multiplication. Parentheses, 2 times 5, which is 10. Okay? Anytime you see this, a square root times itself, very, very important, those cancel. All right, here are some practice examples. Here's what we're going to do. I just want you to try one at a time, and then you can unpause me and check, okay? So go ahead, try this example, and then unpause the video, and I'll show you the solution. Okay, hopefully you tried this first one here. We have 3 times radical 7 times radical 7. Well, that's radical 49. And this just gives us 3 times 7, which is 21. Okay, all right. Go ahead, pause, try the next example, 9 root 3 times 2 root 5. Okay, hopefully you tried this one. Here we're going to multiply 9 times 2. We're going to multiply them together, and then we're going to multiply square root of 3 times the square root of 5. So this gives us 18, and then the square root of 3 times 5 is the square root of 15. 15 is very tempting to break apart, but I can't simplify. There's no perfect square that's a factor of 15, so we're done. Okay, and then lastly, please try the very, very last example. Okay, hopefully you pause this one. Here is the example, square root of 10 times square root of 2. That's the square root of 20. And then we want to go ahead and simplify the square root of 20. Did you simplify it? If not, pause me. And then I'll show you the solution here in a second. Okay, and then the perfect square in 20 is 4. So we get an answer of 2 square root of 5. Okay. Hey, one that's not on here that I have not seen, I want you to make a note of this somewhere, is the square root of 32. I like simplifying the square root of 32 because a lot of people jump at 8 and 4. A lot of people, I'll put this in red, this is what it's not. It is not 4 times the square root of 8, which is 2, root 8, because you can keep simplifying. You can take out another perfect square of 8. What it is the square root of 16 times the square root of 2. You want the highest perfect square. So 32 is a tricky one. It often gets students. This gives us 4 square root of 2, right? If you kept going with this red writing here, you could have done this 2 square root of 4 times, I'm running out of room, square root of 2, look at that, I created more, wow, 2 times 2, which eventually gives us 4 root 2. But you see, much simpler to go the blue path. The blue pill or the red pill. Have you guys even seen The Matrix? Do you know what The Matrix is? We're living in it. All right, next property or next topic that we're going to talk about is division. We're going to divide some square roots. Now we've covered these first 2 properties here. Now let's go ahead and look at, property 3 we've talked about, property 4. So property 4. And this really, property 4, is just called rationalizing the denominator. Rationalizing the denominator. In mathematics, we cannot have a square root in the denominator because we cannot divide a value by a value that has a square root. It doesn't make sense, right? Splitting up into piles. So we multiply by a radical, by the square root of that value, top and bottom, because this really right here is just 1. Isn't this equal to 1? So I'm not changing it. I'm just kind of just changing its look. It's like when you put on makeup, right? You just change your look. Or when you put on, a different outfit, you can change your look, okay? And what happens is the result of multiplying a radical times itself, and we'll look at an example here in a second, is that you get that radical squared, which these end up canceling. And so you just get a whole number in the denominator, okay? So this is our strategy. You're going to multiply by the ratio of 1. Again, it's just whatever is in the denominator, you multiply top and bottom by that same value. You reduce rational numbers if possible. So after we do that first step, don't always take for granted that we're done. We may have to simplify. And then we go ahead and write our simplified answer. So here are our first 2 examples. Let's look at this one first. We have 3 divided by the square root of 2. And what I'm going to do right here is I'm going to multiply by a ratio of 1. Multiply by a ratio of 1. So this is, I'm not changing it. If I multiply something by 1, isn't it the same thing? So I'm going to multiply by the square root of 2 times the square root of 2. Again, because I want to cancel out that denominator, that square root in the denominator. So when I rewrite this, in the top, we get 3 square root of 2. And in the denominator, square root of 2 to square root of 2. Hopefully by now that you have recognized those square roots cancel, and we just get 2. Okay, if you put square root of 4, again, you can simplify that, but that's more writing. And I know you guys like less writing. Well, maybe some of you, most of you. So there's our answer, 3 root 2 divided by 2. Okay, next example. 9 square root of 6, okay? Multiply by a ratio of 1. Multiply top and bottom by the square root of 6. This gives us 9 square root of 6 over 6. Not too bad, right? But here I can reduce by 3. Here I can reduce by 3. And I can only do it to the whole numbers, the rational numbers outside of the square root. So like 9 and 6, I can reduce by 3. I cannot reduce the square root, so don't touch the square root. The square root is protected. It has a force field. It's wearing body armor. However you want to look at it, okay? We can't touch it. So I'm going to go ahead and reduce this by 3. That gives us 3. This gives us 2. And then our final answer is 3 square root of 6 divided by 2. Okay, I have some practice examples for you. Please pause the video and try these examples. All right, here's our the first one. I'll go ahead and show you. I'm just going to multiply top and bottom by the square root of 5, like this. So we get 6 square root of 5 divided by 5, and we're done. That was pretty easy. The second one, don't be scared by those numbers. Just follow the same process, and trust me, you'll be fine. Okay, hopefully on this one, you tried it, you multiply by the square root of 14, and you get 16 square root of 14 over 14, which, hey, that's not too bad. Did you simplify or did you reduce? Here we can reduce by 2, so we get 8 square root of 14 over 7. Okay, here is our last set of practice examples. Please try these. Okay, hopefully you get to try these. Here is the solution to these examples. And for 7 square root of 10, you multiply it by square root of 10, and you get 7 root 10 over 10. So no simplification here on this example. And then for the next example, you multiply by the square root of 3. And so we get 12 root 3 over 3. But you do want to simplify the 12 and 3, reduced by 3. And you get your final answer, which is 4 square root of 3. All right. Hopefully in this video you were able to multiply and divide simple square root expressions, and then your success criteria. Did you simplify a square root? Were you able to do that? Awesome. Were you able to multiply 2 square roots and then simplify when possible? Good job. And then did you divide an expression with a square root in the denominator by rationalizing that denominator? Go ahead and say that with me right now. Rationalizing the denominator. All right, that's going to do it for this video. Like, subscribe. I'll catch you in the next one.